can get to know some more about chemical and biological engineering. With us on the call today, we have Camille Milo, who is a senior in chemical and biological engineering and biomedical engineering. We have Dr. Brad Riesfeld, who is one of our professors in the department, and he teaches our first year class in the spring in addition to a couple of other classes later on in the program. And we also have with us this morning Jackie Goldring, who works for the College of Engineering with a lot of our prospective students on recruiting. And I believe Denise Morgan is also on the call this morning, and Denise is our department admin assistant. So I'd like to welcome you all, and I'm going to let Brad get started. Thank you.
Good morning, everybody. Does everybody have access to the chat? I hope. I apologize for my lack of a camera. It's a little embarrassing being an engineer and having technical issues, but in any case, it's wonderful to have everybody here. And the point of today's presentation and the other materials is to give you a sense of what chemical and biological engineering is all about. If you have access to the chat, can you just type in briefly where you're from, what you're interested in, that sort of thing? In any case, while that's going on, as Claire mentioned, my name is Brad Riesfeld. I'm a professor in chemical and biological engineering, and I'm also the director of undergraduate education. Oh, welcome everybody. Thank you so much for sharing this information. And along the way, if you do have questions, feel free to type them out and we'll try to make sure that we answer whatever concerns or questions you might have. So again, welcome to Engineering Exploration Day. And without further ado, what I would like to do is consider some interesting sorts of real life situations. So next slide, please. All right, so what I'm going to do, in case you have to step away or whatever, is I'm going to go ahead and read these to you, so please don't feel insulted by that. So we're going to look at a few different sorts of real life scenarios. So the first one is here. After many months of study, a promising new anti-cancer drug has been developed by your group. In animal experiments, it is showing a lower blood concentration than expected, but a higher incidence of liver toxicity. What's going on? Is there a way to save this drug from elimination as a potential therapy? So let's think about that for a little while and what that might involve. So let's move on to the next one. All right, your group has learned that small amounts of a mixture of certain solvents or contaminants have been found in a local water supply of a number of homes in your community. Where is it coming from? Does this pose a threat to the health of the community members? If so, how can this hazard be mitigated or eliminated? Let's think about that problem for a little while. Next. Your division is studying the potential of a revolutionary new battery that would have many times the power density of that of the current best batteries. However, the battery requires a novel membrane material with certain specific chemical and physical properties. What synthesis methods and chemistries are available to make this material? Can we produce this kind of material economically in large enough quantities? Next, you have become aware of a serious problem associated with deficiency of an essential dietary nutrient in a certain region of the world. Through some research, you have found that certain plants in that same region produce small quantities of this nutrient. Can these plants be engineered to upregulate the production of this nutrient to increase the amount? Is such an idea even feasible as a way to help the people in this region? And let's look at our last scenario. With water temperatures rising, a new type of algae has emerged in the environment. You have learned that this new species has an extremely high growth rate and lipid content. It occurs to you that this could represent a new energy source. What processes would have to be used to extract the lipids and produce a useful biofuel? Is such an idea economically feasible? So what do you think is the common thread between all of these different sorts of situations I've just described? Any responses in the chat? What do you think? A really wide range of different things, from biotechnology to material science. What's the common link? Any ideas? So modifying the environment, adjusting it to help the world, that's a great thought. So let's go to our next slide. And really, what I'm getting at here is, even though these applications seem really diverse, the common linkage is they're all chemical and biological engineering. So from biotechnology to clean energy to medicine to environmental health, these are all areas in which chemical and biological engineers are involved. And so the idea here is that chemical and biological engineers take their base knowledge, so that's in math, physics, chemistry, biology, and engineering, and build things, processes or devices that can provide solutions to some really interesting and challenging problems around the world. So how many of you are kind of interested in the mathematical aspects, or what's your favorite subject in school? Can you give me some feedback on that? Are you a math person? Biology, math, awesome. Science, physics or math? That's great. Awesome. Thank you very much for your input. So if you do have an interest in these different areas, chemical and biological engineering could be a really good fit for you. So let's go to the next slide and talk about what chemical and biological engineering students learn about. So this gives you some idea of some of the areas of study. So there's many foundational types of courses that you would take in college, from calculus to physics, chemistry, and biology. You'd also be taking at CSU some humanities and social sciences. And once these foundations are in place, you'd be ready to undertake some of the courses that are more related specifically to chemical and biological engineering. So those are things like understanding chemical reactions and then being able to use that knowledge to build chemical reactors or interesting kinds of devices. Thermodynamics, that has to do with energy, transport phenomena, as is mentioned here, fluid flow, how does fluid move around, how does heat move, how does mass or different elements move around in different kinds of processes. In addition to all that, the program in chemical and biological engineering at CSU, we have a lot of emphasis on teamwork, communications, professionalism, and ethics as well. So one thing that's really great about the CBE program, and actually a lot of the engineering programs in general, is the idea that over the course of your academic career, you take a lot of courses that are all building towards a capstone. And your capstone happens in your senior year, where you undertake a really challenging and interesting problem as a team, and you're solving that. It may be a problem that comes from industry. It could be a problem that comes from a faculty member or from a professional organization. And so the culmination of your experience is then working on a real life sort of a problem and applying all of the knowledge that you acquired along the way. So here's a few examples of some of the projects that students have worked on over the past few years. So you can see there's, so if you have an interest in clean energy or renewables, that's a very popular area. Biotechnology or biomedicine, there's a lot of projects in those areas. Process safety is another area that's of great interest. Pretty much all of those sorts of topic areas I mentioned earlier are subjects for senior design. And the really cool thing is that as a senior, you get to present your results in a large engineering E-Days fair, where everybody gets to see the results of your projects, and you get to see what cool things other engineering students have been working on. Does anybody have any questions so far? Anything in the chat that you're curious about at this point? Okay, let's go to the next slide. So on this slide, I've tried to capture what I think are unique aspects of the CBE program at CSU. One of the things I'm really proud of is that we have a very good rapport between students and faculty. Aside from advising from Claire, who's a super advisor, you'd also get to be matched with a faculty member who is able to share some experiences with you and act as your academic advisor during your stay at CSU. Also, I'd say probably all of the faculty in the department really like to get to know students, and over the course of your 4 years, have a pretty good idea of all of the students within the program. We also value teaching and advising, as I mentioned. That's very important to us. We also are able to bring our research into the classroom, some of the results there. My own research is in the area of pharmacology and toxicology, and I try to bring those topics into the courses that I teach. We have awesome students in the program, and it's really a pleasure to work with them all the time. Another thing that makes our program unique, I believe, is that there's a lot of opportunities for students to become engaged in research while they're at CSU. For instance, I have, I think, 8 undergrads working in my group right now. starting even as early as sophomore year. So overall, I think our program emphasizes strong teaching, research opportunities, great students, and really a pretty collegial and friendly environment. So let's talk a little bit about opportunities for chemical engineers and chemical and biological engineers. So this pie that you're seeing is meant to indicate the different sectors that a CBE could work in. And the main takeaway here is that there's no single area of employment. In other words, we don't have all of our students going into chemical processes. As you see, there's ranges of sectors from chemicals to fuels to biotechnology to food science. And as you'll see in a little while, our graduates go to a number of different types of places once they graduate. So a great diversity of opportunities because students know or have a lot of different skills, again, in these areas of math, math, engineering, biology, chemistry, etc. So next, just show kind of a brief snapshot of some of the companies that are where our graduates have gone. So we see BP, which is petrochemical, Genentech, biotechnology, Halliburton, which is a large engineering company, IM Flash, which has a close relationship with our department. They make semiconductors. Epic Health Services, so we have graduates who have gone into health-related areas. Anheuser-Busch, obviously a beverage company. And we have a number of students who go on to graduate or professional school as well. So some students go on to medical school or law school or go on for their master's or PhD in chemical and biological engineering. And then finally, just talk a little bit about the compensation. This gives a snapshot or some idea of salaries that result based on a certain number of years out in industry. So you can see that the entering salaries for chemical and biological engineers are very competitive, among the highest in engineering. And there's pretty steady growth in terms of salaries. Of course, it depends a little bit on what sector you're in and what part of the country. But in general, this can be a very lucrative and a really, really challenging and interesting occupation to go into. So overall, we have a very strong program, I believe, and we really welcome students to ask more and to either visit us or to ask questions along the way. And so we have the opportunity today to answer whatever questions you might have. In the future, if things occur to you, you're free to reach out to us, ask questions of Claire or me, others. Just about everybody in the department's happy to answer any kinds of questions you might have. So is anything, does anybody have any questions at this point about the department or about the profession, anything that occurs to you?
Dr. Riesfeld,
Yes,
I know that you teach, I don't know if you still do you still teach the first year CBE lab?
I do.
Do you
Yeah,
want to kind of talk about like the CBE lab a little bit and like what we do and the projects that we do?
sure. So Dr. Reardon may have a video showing some of that, but the first year CBE course which is CBE 101, teaches students the basics of chemical and biological engineering. So some of the problems and interesting applications that you might face in the curriculum and in terms of a professional career. So we work on different ranges of problems, and then there's a lab component where we look at a number of different sorts of things. So this year we have an experiment where we look at enzymes. So enzymes that can act on wood or wood products, so cellulose, and to turn those into sugars. We have a lab that where you get to make your own spectrophotometer, which is pretty cool. You get to make it out of Legos, interestingly. And it works pretty well, actually. There's labs about solar energy, labs about fluid flow, and about heat transfer. So a pretty good range of really interesting and challenging labs that go beyond what, let's say, what you would have in maybe a typical chemistry lab, where you have kind of a recipe to follow. In our labs, we like to have even design their own experiments to be able to answer those. So I hope that helps a little bit. What other questions can I answer for you, or our student ambassadors or student representatives? So out of those sort of scenarios that I showed you earlier, did any of those strike a chord with any of you? Any of you interested in biotechnology or materials or clean energy? So up on the screen right now, we have Professor Reardon.
Hi, everybody. So so the reason that I'm delighted. Anyway, I'm definitely happy to talk with you and answer any questions you can. But I have a special perspective because, like Dr. Riesfeld, I'm an instructor of the CB 101 courses that are the kind of the starting point in our curriculum. Um, this is a course that has the real purpose of helping all of the students understand better what it is that chemical and biological engineering actually is, and so a little bit of what you've heard about so far. But we spend the whole semester on it. We talk about where you can go with it, and I think Dr. Riesfeld has mentioned a few of those things, but also what it really means, what it's really like to be in an engineering course, as kind of an overview of what you'll take later on. So we, instead of just hearing that there's, you'll take what is heat transfer? Most of us don't really know what that is. And so we do a little bit to help you understand what it is that you'll be getting into, what it means to think about, develop engineering thinking and engineering problem solving skills. And so it's meant to be I think an interesting and lightly challenging introduction to what engineering can be. And I also bring in a lot of alumni to talk to the students so you can hear directly from each of them where they've gone, how they've used their CB degree, what kinds of interesting things that they're doing. And maybe that can be inspiring to you. I know that certainly it was the case for me, and I think it's really the case for probably 99% of our students, that we think we're interested in this, but frankly, there's no real way that we have to learn more, to understand really what you can do with CVE. Um, and and so I just started because I thought it was worth a shot. And I'd like to help all of you and all of the students in my first year course know, be a little more certain that this is a good direction for them, at least a great place to get started. So I see, let me just tell you a little bit more about what we do in the CB 101 course. We've got a part that's on, it's kind of a classroom oriented part where I tell everyone about the basic principles of CBE, and you learn to do some problem solving and how to you learn the basic concepts that are really underpin CBE, and you see where they can take you in these different areas of energy and biotechnology and so forth. And we also have a lab part where we do a mix of experiments, working in groups, but also activities that help you develop group skills, because engineers work a lot in groups, not only with other CVEs, but also with other kinds of engineers, and often in groups that have mixtures of engineers, scientists, and non-technical people. So we have a little video of one of those activities that we did just a few weeks ago. And what we're doing here, the students are learning about calibrating water flow meters, and then you see that's on the gray carts that you see here. There's a pump and a flow meter. And then also there on top of some of those carts, you'll see that there's a green box, and that's a solar water heater. And so it's a simple solar water heater, but it's effective. There's one. And it allows the students to get experience with measuring, in this case, temperature and flow rate, but also then in doing some calculations that help them to understand, for example, energy efficiency of these solar water heaters. And you can see that they're working in groups. We have the guy kneeling down in the front is one of our technicians who's helping them understand, and there's other people around. So we have lots of help with this course, so that the students in the course really, they're figuring things out, but they're figuring things out with a lot of guidance. And I think it's this kind of experiential learning that, combined with what we're doing in the classroom part, to understand what's behind the measurements and what is energy efficiency all about. It's how you can more directly understand where a CB degree can take you. So if anybody has it, I'd be happy to tell you more things about the course. And I see some things in the chat that our ambassadors are really doing a great job of answering. But you can put your questions for me in the chat, or you can just shout them out.
Tell us about your research, Dr. Reardon.
Sure, happy to. So my research, for a period of time, I used my interest in essentially in microbiology and biotechnology blended with CBE principles. At first, the big emphasis was on ways of using all of that to solve environmental pollution problems, how we can use microorganisms in plants to clean up contaminated soil and water. And we actually had a project where we made a bioreactor to clean up the gas emissions, the air emissions coming from a facility not too far away that made aluminum cans. So we did that for a long time. It was just great. I learned a lot about the soil environment and collaborated with people in lots of other fields. that got into what's now called microbiome studies about how microorganisms work together to do things. And then we also, I got to interact a lot with companies and other researchers. At the same time, I actually did a little bit of the kind of work that the research work that Dr. Riesfeld does in environmental toxicology and understanding how we can use CVE principles to understand where chemicals go in our bodies when we're exposed to them. But when the price of oil went up, some now, what is it, about 10 or 12 years ago, a lot, and there was a renewed interest in biofuels as an alternative to petroleum products. And that's what my PhD was actually about. So I got back into that. And among other things, I started investigating how we can use algae as a source of the chemicals, the building blocks for making alternative fuels. And that's what my research program is mostly about now. I look at things like how we can take algae and plant materials and even wet organic waste like food waste, how we can convert that efficiently and cost effectively to not only fuels, but other molecules. And this is, we used metabolic engineering and synthetic biology and CVE principles all together. And it's amazing. I'm really passionate about that as a goal. I think it's a way of not only, we can address things like the energy issues, we can even look into food production, and all while trying to have a better environmental footprint in doing it. And then the other thing to mention is that I'm also been interested in sensors, especially ones that have a biological part to them, biosensors. And about 10 years ago, I started a company to commercialize some of the research that my group had been doing. And so I have a little bit of that entrepreneurial background. So a few things keep me busy, but when we involve undergraduates in our research, and sometimes at the company as well. So it's something that's been really crossing across from education into research.
Thanks for sharing. That's really interesting.
Thanks. It keeps me. I'm I'm pretty excited about it. Yeah.
Any questions for Professor Reardon or myself or students who are on board with us about the curriculum, what you might expect?
Are there any kind of like groups or projects outside of classes that use this kind of technology and engineering to participate in?
Definitely. So there are a lot of there's so many activities that the students can do while they're here that relate to both professional interests and personal interests, and hopefully the two are sometimes the same. That on the professional side, we have the professional society that is representing CBEs called the American Institute of Chemical Engineers, or AICHE. And so we have a student chapter of that. They're very active and do a number of, they bring in the alumni speakers so you can learn more about careers, but also have groups that actively do things like there's something called the Chemi Car Team, where you make a little vehicle that's powered only by chemical reactions. We also, I started about a year and a half ago, I started the Algae Club. It's the first of its kind in the world where the students learn about algae and how we can use it to solve a variety of problems. There's a lot of our students also participate in the International Genetically Engineered Machines competition. So we have a team that's using principles of synthetic biology, very multidisciplinary group, but they use those principles to, well, basically to do a project that they all choose. It's faculty supported, but not faculty directed, I would say. So there is a bunch of other examples. We have lots of students active in the Society for Women Engineers. We have the Engineers Without Borders that does projects to help communities around the world by using their engineering skills to make changes that affects people's daily lives.
There's a student chapter also of Pharmaceutical Engineering
Right.
Society for those who are interested in that particular area. Many, many opportunities to get involved outside the classroom.
Well, I will leave you now to go back. I'm actually talking to a group of alumni, and it's fun to talk with them and to think that they were not so long ago, maybe exactly where you are, thinking about what they wanted to major in, where they wanted to go, and everything. And they chose to come to CSU, and I've yet to meet one who wasn't completely enthusiastic about their experience here, which we're always excited to hear. So I'm just going back to talk to them and to catch them up on what's happened since they left campus. But we'd be delighted to have you join us and to become eventually one of them and one of the CSU CBE alumni. If you have any questions after that specifically about our program, for me, about CBE 101, don't hesitate to point them to Claire or to Dr. Riesfeld, and we'll get back to you as fast as we can.
Thank you, Dr. Reardon.
Thank you, Dr. Reardon.
Bye, everybody.
Thank you.
And thank you to Dr. Riesfeld. We do have some videos from some of our alumni, funnily enough, talking about their careers after they graduated. So I have 3 videos to show you right now. I'm going to share my screen and let you listen to what some of our graduates have done after they left chemical and biological engineering at CSU. So this is Katie Marshall, and Katie graduated a few years ago.
Hi, my name is Katie Marshall. I am a graduate of the CSU Chemical and Biological Engineering Department, class of 2011. Since graduation, I have been working in the oil and gas industry. I started as a process engineer at the Suncor refinery in Commerce City. I moved from an engineering role to a operations supervisor role, and then after finishing my MBA, I went into a production and economics function. About a year and a half ago, I switched to a new company called Refined Technologies. It's a smaller Houston-based company. I still live here in Denver and work remotely, but we help refiners with their shutdown activities, whether that's for maintenance or conversion. And we come in during the shutdowns and help them clean the equipment, decontaminate the equipment, and ensure they meet their environmental and safety compliance during that process.
So that was Katie. And next we have Lucas Gitner, and he graduated 2 years or 3 years ago, I think. And I'm gonna show you the video from Lucas now.
Hello, my name is Lucas Gitner. I'm a chemical biological engineer. Went to Colorado State University. I graduated in 2016. I worked as an undergraduate in Dr. Snow's lab doing protein engineering and protein crystallization. In 2017, sort of out of the blue, I got an offer from a mineral processing company, a multi-conglomerate international company called Imerys. They have minerals that go into basically everything that you touch every single day. Ceramics, paints, plastics, paper, even in your car. Whenever I was first hired, I was a research engineer in the lab in San Jose, California. I began working on a mineral sunscreen. Then I worked on air classification of mica. And my final project was getting a lab scale pinagglomerator and testing it to make densified talc powder for polymer applications to improve dispersion in those polymers. It was targeted for the automotive industry. And, right now, most cars produced in America have about 50 pounds of talc in their bumpers to help reinforce and decrease the amount of polymer that's actually needed. In 2018, I was moved to the pilot plant in Bozeman, Montana. I am a process development engineer, and I work on a smattering of different projects, everything from doing new dust collection for our plant to identifying contamination in some of our ore feedstocks, stearate and silane coatings on talc to help improve insulation in circuit boards or hydrophobicity in medical rubber stoppers. I'm developing a less than 0.1% quartz product for food grade materials in South America. And my biggest thing I'm working on right now is running the project management for installing that pinagglomerator that I began working on in 2017 to help eliminate a bottleneck in packaging in one of our plants. I really enjoy my job because it's so variable. One day I'm working on cutting steel and making some welds to mock up a new piece of equipment that we've dreamed up. Another day I am analyzing some data using MATLAB and doing some coding. And then another day I am helping a Austrian coworker to optimize their plant. I got to say good luck with the chemical engineering degree. I worked really hard, but it was worth it. And I'm now where I'm at, and I love my job. If you ever have any questions about chemical engineering school or, a professional career, let me know. I'd love to help out. Have a great day. Glad to get to talk to you.
Go ahead.
Just to briefly interrupt, when Lucas first came to CSU, I was his advisor. And when he first came, he wasn't sure if he wanted to be a firefighter or go into chemical engineering. And I think he quickly caught the bug, and it sounds like he's doing great. So just one testimonial for all of those of you who are a little undecided.
Brad, can you see Angelo on the screen?
Yes.
Great. So this is Angelo Zito, and he's also one of our graduates, and he's going to talk to you a little bit about what he's been doing since he graduated.
Hi everyone, my name is Angelo Zito. I graduated from CSU in the spring of 2017 from the CBE department, and today I'm going to tell you a little bit about my career since graduation. Right out of graduation, I jumped right into the oil and gas industry. I accepted a contract night operator position with Covenant Testing Technologies. This job was mainly monitoring oil and gas facilities and making sure the production was staying online and troubleshooting problems as they came up. This job really gave me a good foundation of what the day-to-day operations are like from the operator's perspective. In July of 2018, I accepted a contract to hire position as a facilities engineer with Southland Royalty Company, an oil and gas producer up here in Rock Springs, Wyoming. In July of 2019, I accepted a full-time position as a project engineer with the company. Throughout my time here, I've been able to utilize my knowledge and experience as an operator and apply it to the projects we've worked on, and apply it to our standard floor well design, and really been able to take those thoughts and opinions and things that you get from operators and apply them to our design for our new facilities. Recently, I've been promoted to the environmental engineer, and this side of the job has been, a lot of fun learning, the regulatory side and air permitting and all the sort of things that go into that side of the company. I've really enjoyed every single moment of since I've moved up here. One thing I want everybody to take away from my career so far is that just because you don't land, your dream job right out of college doesn't mean it's not out there waiting for you. Keep on working, keep on grinding, and all your hard work will pay off. Thanks for everybody's time today. Stay safe out there, and go Rams.
So that's our alumni videos. And we just have a couple minutes left for questions, if anybody has any additional questions for us. Okay, so this session has been recorded. You will be able to access it again after today. It is on our YouTube channel, or will be, and Jackie has posted the link in the chat. Camille, were there any questions in the chat that we didn't get to?
No, a lot of them were the BME CVE kind of pair, and if I could just chat about it for like 2 seconds.
Sure. Please.
Yeah, so kind of giving the biomedical, and actually let's just do this. I'll turn on my camera. Here we go. Hello everyone. So I'm Camille. I'm a 5th year studying chemical and biological and biomedical engineering. So I'm in my last year, which is super exciting. And a lot of the questions that I saw about biomedical engineering were like, how well does chemical and biological engineering fit with biomedical engineering? And just to give you a quick synopsis of why we do the dual degree in biomedical engineering. So biomedical engineering is a really broad field, right? You can go into pharmaceuticals, you can go into prosthetics, or you can go into the electrical components of any type of medical device. So if you're doing CT scans or MRIs, like an electrical engineer would be kind of in charge of that. So when CSU was looking at biomedical engineering, right, they saw that how broad it was. And so to be able to pair it up with chemical and biological engineering, you can go into things like biomaterials and pharmaceuticals. And so those are actually 2 of my main interests, is understanding how to be able to use medications with like cancer drugs or any type of virus illness. In fact, one of our senior design projects right now is finding a COVID like rapid test. And so that's something that we are working on, not me personally, but like people in my class are working on. So I would say that if you are interested in kind of if you're interested in biomaterials, and one of the questions that I usually get is, what is the difference between like prosthetics and biomaterials? One of the questions I usually ask students is, are you interested in making the actual prosthetic, or are you interested in, say, someone is allergic to the silicone or whatever is being used in the prosthetic? Do you want to be the one in charge of understanding those biomaterials to be able to fit onto the prosthetic? So that's kind of the distinction between mechanical and biomedical and chemical and biological with biomedical. But yeah, just kind of a little bit about my experience. I've loved it here at CSU. I thought that they have thought about everything in terms of understanding, how broad of a major biomedical engineering is, and also chemical and biological engineering. To go through these 4 years of chemical engineering, I've learned bits and pieces of chemical engineering to be able to fit what I want to do with chemical and biological and biomedical engineering. So kind of my biggest advice for students going into engineering is, you'll learn about little bits and pieces of everything. And, sometimes some classes aren't the best. Like Dr. Riesfeld was talking about thermodynamics. And I was like, oh, that hurts a little. I didn't really like that class, but it's something that you will learn, and you kind of just have to learn through it. But it's not going to be your favorite thing ever. And then there are classes like transport phenomenon that I took my 4th year that I fell in love with, right? So just keep that in mind, that not everything in engineering will be your absolute favorite, but that is a way for you to be able to understand what you want to do with this major. And I don't know, I just love engineering. 5 years in, I'm still here, and it's been my favorite thing. So yeah, like Jackie said, Jackie's down there in the chat. If you do have any questions, please feel free to reach out to any of us. I'll also drop my personal email in there as well. And if you guys have any questions about CBE, just CBE by itself, or chemical and biological with biomedical engineering, please feel free to email me.
It's awesome, Camille. Thank you.
And I just put my email in the chat as well. So feel free to reach out if you've any questions. If you have questions about, I saw some questions about AP credit, transfer credit, dual enrollment credit. Just reach out and we can answer those questions for you. Thanks, everybody.
Thank you.
Thank you.
We look forward to seeing you.
Thanks, everyone. We look forward to seeing you at more sessions this week.